So last week, I go over it quickly, we did multiplying fractions. So why don't you all try this problem? 3/7 times 4/3. Just to practice. My computer locks every 30 seconds. I need to change that. Alright, do we get an answer? Or still working?
I mean, I multiplied the two top numbers,
Yep. What answer do you get?
12.
Uh-huh.
And I multiplied the two bottom numbers.
That's it. Good. So to multiply a fraction, just put them in order like this, multiply top by top and bottom by bottom. Alright, now I'm gonna ask, oh, I gotta bend over and tilt it. Oh, now I'm gonna ask you to do, times do this one and then give me the simplified version of it.
Simplified.
Yeah, simplify it for me.
When I'm simplifying, am I cutting the numbers in half?
You want to find a number. Well, you both have the first answer, the unsimplified one.
10 over 20.
Yeah. So you got Jermaine?
Yes, so, but we simplify that again, let's go break down even further.
Yeah. So when I say simplify, what I mean is we look at both of these numbers, 10 and 20, and we see what do both of these divide evenly by.
5.
5. Yeah. So let's divide each by 5. We get 2 over 4. Can we simplify it further?
I got 5 over 10. Okay, so then that would have been 2.
So can we simplify 2 over 4?
Yeah, we need to.
Divide by 2. 1 over 2. You can't simplify that further. We divide it by 5 here. That's perfectly fine thing to do. But the thing about simplification is you can do it in whatever order you want. Like we could have done it like this. We could have done divide by 2. We would have gotten 5 over 10. Then we would have had to divide by 5. We would have gotten 1 over 2. We
Yeah,
can
because I
even-
got 5 over 10 and I was just going to stop there.
Yeah, you want to make sure you can't go any further. The quickest way to do this one is divide by 10, and then you get 1 over 2 right away. So that's the quickest way to divide down. So if you divide the biggest number you can find that they both have, and this is called the greatest common factor, where we've talked about factors like the biggest factor that both of them have in common. If you do that, then it'll be totally simplified. All right, so let's talk about dividing fractions. This one's a little more complicated. We're re-talking about divide fractions. Now let's say we have 2/3. We're dividing that by, I don't know, 1/4. What do you get? answer? What answer do we get?
2/1.
2/1. Alright, so how did we get there?
I think I divided 2 divided by 1, 3 divided by 4.
Okay, so here's the, we got,
But you have still one left. No, never mind.
we have to follow a process called KCF. Keep, change, flip. So first thing we do is we keep the 2/3, then we change, so I'm gonna do K, C, we change the division symbol to a multiplication symbol. Now we flip, we used to have 1/4, we flip it to 4/1. And then we can do the math problem. 2 times 4 is 8, 3 times 1 is 3, so 8/3 is the answer to that one, because of this keep, change, flip. Let's try another one. How about we try, 1/4 divided by 9/10. Remember, keep, change, flip. And continue trying to figure out how to fix this setting so it doesn't block while I'm teaching.
So I keep 1/4, change the division to multiplication,
Yeah,
and then flip so it'll be 10/9.
exactly right.
So I got 10/36. Is that correct?
So you got Jermaine? It's correct, but it's not simplified. What is it if you simplify it?
5/24.
Divide by 2. Are you dividing by 2?
5/18.
What are you dividing by to get?
Divided by 5.
Well, 36 doesn't divide by 5.
Divided by 3.
10 doesn't divide by 3. 2. They're both even numbers. Divided by 2. Divided by 2 is 5/18. You can't simplify this any more than that because the only thing 5 divides into is 5. 18 doesn't divide by 5. Good. I think you'll have the hang of it. I still haven't figured out how to change this max settings, so I think my computer's going to keep going to sleep every time I turn my back. Let's keep talking about fractions. We're going to talk about finding common denominators. So first let's talk about 2 kinds of fractions that are kind of unfortunate because they're weird. So improper fraction. Then we're going to have this one, a mixed number. Alright, so we've got 2 kinds of things going on here. We have, I'm going to write this here. So sometimes our number is greater than 1, but we want to write it as a fraction. So, like normally when we think about fractions, say think about a gas tank or think about pizza, you can't exactly, unless you order more than one pizza, have like more than one pizza, and you probably don't want your gas tank more than 100% full, or you got like gas somewhere that's not the gas tank. But there are situations where you might want to say like, I ordered 1.5 pizzas, so you need to talk about a fraction that's bigger than 1. So how you know a fraction is bigger than 1 is when the number on top is bigger than the number on the bottom. Because what is 3, the fraction 3 over 3? What does that reduce to if you simplify it? 1, because we can divide each top and bottom by 3, it becomes 1. So whenever you have a number over a number, it's 1. Like the same number over the same number is 1. So this is bigger than 1, 4/3. And so we call that an improper fraction when it's bigger than 1. This is a mixed number. It's when, this isn't a very pretty way of putting it, 1 and 1/3. It's when you have a regular number, and then right beside it you have a fraction, and they're like the same. They're the same. It's the same number. They're just expressed 2 different ways in the same number. So this would be like saying I have 1 and 1/3 pizzas. So if I say I have 1 and 1/3 pizzas, I could have 1 pizza here, and then like a third of a pizza here, even though that's not a good drawing of a third. So you can go back and forth between these numbers. So the way we can do that, I'm going to show you how we get to 1 and 1/3 from 4/3, is you can say how many times does 4 go into 3? How many times does it? 1? 1. And then how many are, so that's 3 times, that's 3. So if we take 3 away from the top, there's 1 left, 4 minus 3, so that it's in 1/3. So that becomes this number. Now we can go backwards in the same way. This time we say 3 times 1 is 3. Then we say plus 1 is 4. And then we use the same denominator, 3. So let's try that with another number. Let's try that with 8 over 3. So what would this be as a mixed number?
So,
1 over 3,
1 over 3?
2 over 3.
Well, we've got to have both a number and then we've got to have a fraction.
so it'd be 2 over 3. So, yeah.
So talk to me about how you get that, Jermaine. That's right. Talk it out.
Alright, so let's do the, how many times can 3 go into 8?
How many times does 3 go into 8? So we say 8
Twice.
divided by 3 is 2, right?
Yeah.
So 2,
And just 2 left.
and there's a remainder of 2. There's 2 left over. So you get 2 over 3. That little r means remainder. Another way you could do it is 3 times 2 is 6, and 8 minus 6 is 2. So that would be this 2. Why don't we try this one? 13, well actually we're going to do it this way again. Let me erase. I'm going to erase this one. We good with this one?
Mm-hmm.
Okay. Let's try this one. 13 divided by 12. Or 13 over 12 is a fraction. Have an answer?
I got 1 over 6.
1 over 6. Alright, talk me out. So I
I
see.
did 13
Mhm.
goes into 12 one time.
Yep, that's right.
I mean, 12 goes into 13 one time.
Yep, that's right, yeah.
And then the 12 cut it in half. I got 6.
Yeah, so you don't have to cut it in half. The bottom number here is gonna be the same.
So it's always gonna be the same.
Yeah, so 12 times 1 is 12. So it goes into 13 one time.
One time.
We can say 13 minus 12 is 1. So that 1 goes up here, then the 12 remains. The
So
denominator
the
always
12
stays.
remains. Okay.
Yeah.
So the denominator stays the same.
The only exception would be if somehow it came out to like, you could simplify this, but you would not simplify until you got it figured out. So try this one, for example. Let's try, I'm just gonna make it a little different. Let's try 14 over 12. Alright, so what is this one gonna be?
1 over this. Is it the same thing?
Well, this is 14 instead of 13. So how many are left over now?
2.
2. So you have 2 over what? 2 over
2
12.
over 12.
But we can actually simplify this. What does 2 over 12 simplify to?
1 over 6.
Yeah, so we can say 1 and 1 over 6. Alright, I got one more problem for you all at work. Challenge 1. I think we can do it though. Let's try 19 over 4. So take some real math genius level stuff.
Oh, that's not me.
It will be. Don't worry. Wish I was more of an Apple genius. Figure out. I've changed this setting before. Do we have an answer?
So I put 4 goes into 14 4 times with 4 remaining. Would that be 1 with 4 over 4?
Say that again. Say it
Or
again.
did I get lost? I put 4 goes into 14 4 times.
Oh, this is this is like 19.
I mean,
Yeah, but it does go to 19 4 times. Yeah, that's right.
sorry, that's what I meant. That's what I meant. 19.
Okay.
Yeah. So I got 1 with 4 over 4. Or did I
Okay.
do something wrong?
So what is 4 times 4?
16.
16. So you then say 19 minus 16 is 3. So then our fraction is 3 over 4. Does that make sense that
Because the denominator never change.
say again?
Denominator.
Yeah, the
never change.
denominator never changes. Yeah, well, we're using the big math words in this, we're not saying top and bottom. Numerator, denominator. Next, he's gonna start calling potatoes. Let's try this one. We're gonna go the other direction now. 2 3/4, and I'm gonna change my marker, so we're gonna start this one. Now I want you to go this way. I gotta change markers. Much better.
We're changing a mixed number into an improper fraction.
Yes, that's right. We're going the other direction now. You want me to explain this one?
Yeah.
Alright, so the first thing we need to do is we need to multiply these. So 2 times 4 is 8. Then we add this one. We add the top number. And I'm not going to put the plus there because that makes you think you're adding 2 and 3. So you say 8 plus 3 equals 11. And then you just use the same denominator, 4. And then you're all set. Easy peasy. Here's going to be your next practice one, 5 1/4.
Before.
Let's see. So you got, so 4 times 5 is 20, plus 1 is 21, over 4. Good, I think we're feeling good with this. Congratulations, you finished it first. Good job. I'll try to do one towards the end. Give you. Alright, so sometimes when we have fractions, we need them to have the same denominator, which is the number on the bottom. So, like, when we were multiplying fractions, we could do like 1/4 times, let me do 1/2 times 43 over 75. Like, that's kind of crazy, but it doesn't matter for multiplication because you just go multiply 43 over 150. That's fine. This will not work if we ever need to multiply or subtract fractions, and that's what we're going to grow up towards as we're learning tonight, is multiplying and subtracting fractions. They have to have the same denominator. You will go to fraction jail and meet the fraction police and wish you'd never been born if you ever try to, like, do this. That's wrong. You can't do that. You cannot do that. That is, that's supposed to be no sign. Probably.
But it would be 2 times 3, and that's how you get the denominator?
No, that's not what we do. We don't do any of that multiplication, we're not adding. First thing we're going to talk about is getting fractions to have the same denominator. So let's talk about those. 1/2 and 1/3. I think those are the examples I used. So what happens if we multiply anything by 1?
You get 1.
Huh?
You get the same number back.
You get the same number back. Now, if I have 10 dimes, how much money do I have? $1. If I have 4 quarters, how much money do I have? If I have, I don't know, if I have a dollar bill, how much do I have? $1. Like, they all look different. 100 pennies, still $1, but they're still $1. In the same way, we can write 1 a bunch of different ways. This is 1. This is also 1. This is also 1, 3 over 3. Why are these all 1? It's supposed to be 4. Why are these all 1? If you simplify, it's going to be 1 because you're dividing the number by the same thing. It's going to be 1.
Yeah, because 2 goes into 2 one time, 3 goes into 3 one time,
Yep.
4 goes into 4 one time, and 1 is 1.
So this is a trick we're hopefully going to use so much you don't even have to think about it, because it's going to let us do surgery to fractions functionally. Like, we're going to be able to do things to fractions that we wouldn't be able to do otherwise. So keep that in mind, these are all 1. So to make fractions have the same denominator, we need to multiply them by 1 in a way that makes them have the same denominator. How can we do that? So let me show you this first one as just an example. I'm going to multiply this one by 3 over 3. I'm going to multiply this one by 2 over 2. Now this looks like we're multiplying them by different things because these are different looking numbers. There are 3's here and there are 2's here. You see that? However, this is actually 1, right? This is actually 1. So we're doing the same thing to both numbers, so that's completely fine since it's the same thing. So let's now we can multiply across 3 over 6, 2 times 1, 3 times 2 is 6. So miraculously, we now have 2 numbers with a denominator of 6, which is good, that's what we want. You have to do trial and error with this sometimes. I was able to just kind of look at it and know I should multiply each of them by 3 over 3 and 2 over 2. Sometimes you don't know that right away. So let's try this one together. Let's try, we want to get 1/5 and 2/6 to have the same denominator. So what could we multiply them by to get the same denominator? What's important is the denominator is the same. Well, I'll tell you, we can
1 over 2. So 1 over 5.
What are you saying we can multiply by? It's got to be the same number on top and bottom. So you're saying you want to what are you saying you want to, you want me to like give you guys hints here? All right, so what if we do this one 6 divided by 6? And what if we do this one 5 divided by 5? 6 times 1 is 6, 5 times 6 is 30, 2 times 5 is 10, 6 times 5 is 30. Now we have these numbers. Does this, and this checks out. 2/6 is a bit bigger of a number than 1/5, and 10 over 30 is bigger than 6 over 30. You following my general process? Okay, let's try it with 1/2 and 4/9. And on Canvas this week, I'm going to put a common denominator worksheet. You don't have to do it, but I do want you to do it if you're having trouble with this, because this is going to be really important to be able to do really quickly. And as you practice it, you'll be able to do that. So what do we want to multiply these by, do we think? What are we feeling?
Okay, so the half by itself, like 1 over 2 divided by 2.
Sorry?
So 1 over 2 multiplied by 1 over.
It's got to be the same number in the numerator and denominator.
Three over 3.
3 over 3, okay. That's going to give us 3 over 6. Can you multiply 9 by anything to get 6? No, so that one won't work because you got to be able to do something to 9 to get it to have the same denominator. Want to try another number? Well, 2 over 9 is not 1. It's got it at the same top and bottom.
So 9 over 9.
9 over 9, you say?
Yeah.
Okay. 9 over 18. What are you going to do this one now? 2 over 2. 8 over 18. That works. I got one for you all to practice. I think I saw some light in your eyes. It's wonderful to. Oh, sorry. Did I erase that too soon? Or are you good?
Wait, that was 2 over 2, right?
Yeah, 2 over 2. Yep.
Okay.
I'm gonna erase the top one. I think you got that one. Go with the bottom one. Okay.
Yeah, I'm good.
I saw so much joy in your eyes when we were doing this math. So this one's harder. 7 over 12 and 3 over 4. And my hint to you is look at the 3 over 4 first.
I'm looking at the 4 first.
Yeah, look at the 3 over 4 first.
2 over 2.
2 over 2, let's see what we get. 6 over 8. I don't think we can multiply 12 by anything to get to 8 in the denominator.
Let's do 3 over 3.
You want to do 3 over 3? Okay. 9 over 12. Now what do we multiply the top by?
Multiply by
No,
2.
no. You don't have to do it by anything. We have a 12, we have a 12. We're there. See?
So then the top would be
It's just 7 over 12. I mean, technically, we could say you multiply by 1 over 1, because that's
and
1.
it'll be 12.
But all we care about, sorry, this 2 looks like a, I don't know, like a seahorse that got run over. Like, all we care about is having the same denominator. It's not, we're not just doing math for the joy of doing math. I know a lot of you do that before you go to sleep, but we're not just doing math, like, because we love math so much. We're doing it for a goal. And the goal is to have the same denominator. So now let's talk about adding and subtracting fractions. And I'm going to teach these kind of at the same time almost, because they're like the same except you change the sign, unlike multiplying and dividing. Adding and subtracting fractions. All right. So I'm going to call this step 0, because before you can do either of these things, they have to have the common denominator. Remember what I said about, like, don't ever try to deal with them if they don't have the same denominator. The fraction jail's coming for you. They have to have the common denominator. So if they don't, then you need to do the common denominator. Then add or subtract numerators. And you leave the denominators alone. The denominators are frozen, you don't want to mess with them, it's bad news. Alright, let's, here's an example for you. 1 over 4 plus 1 over 4. Same denominator, we're good. So the answer is 2 over 4. And we can simplify that to 1 over 2. Does that make sense? The hard part here is finding the common denominator. If they have the common denominator like these do, which is 4, you're totally good. You don't have to worry about anything. Let's try this one. 9/16 minus 3/16. When we do this one, we're going to get 9 minus 3 is 6 over 16. And then we can divide by 2 to simplify, is 3 over 8. Alright, these next ones, I think you guys have this part down, right? This next one I'm gonna have you do. I'm gonna put 2 of them up, let you work them. 2/3 plus 4/3. Then 4/12 minus 1/12. what did we get here? For the first one.
For the first one, I got 6 over 3. I didn't know what number to divide it into.
Okay, what about the bottom
Can I
one?
do divided by 1?
You can do divide by 1, but you're gonna get the same number. What about 3 for this top one?
Divided by 3?
Yeah, divide both of them by 3. What do you get?
1 over...
Not 1 over
2 over 1.
1, which is what number? That's just 2, straight up 2. Because if you divide anything by 1, it's the same number. Does that make sense? So 6 divided by 3 is 2, 3 divided by 3 is 1.
Oh,
2
I get what
divided
you're
by
saying.
1
It
is
would be
just
2.
2.
Yeah.
Yeah, if it has a 1 as a denominator, you just
It's
ignore
the
it.
same, yeah.
Yeah. It doesn't even exist in a way. What about this one?
3 over 12
Uh-huh.
divided by 2.
Well, 3 doesn't.
Well, I
divide
didn't
by
get that
2.
far. I just
Oh,
got
okay.
3 over 12.
Oh,
I was,
okay.
yeah.
Yeah, what do we want to simplify it to?
1 over 3.
Divided into, yeah.
Divide by what?
3 over 3. So that's gonna get 1 over 3.
So you get 1 over...
You get 1 over what?
3.
No.
No, 4.
4. Yeah. 3 times 3 is 9. 4 times 3 is 12. Alright. Pretty good. Pretty good. Let's try. I'm gonna give you 2 more. I think you're good to practice. Let's try. Where'd you go? Where are you? 5 6 plus 2 sixths. And let's try 13 over 8 minus 7 over 8. This would be an example where you do not want to change these to mixed numbers because that would make all your math so much harder. Ready? Or need some more time? What do we think? What do we think this first one is?
7 over 6.
Yeah. Do you agree with that one?
Yeah, 7 over 6. And the other
Can you
one is...
simplify?
No.
No, you
It's gonna be a
can't.
mixed number.
You can make it into a mixed number, but I don't care about that. 7 over 6. What about this next one?
20 over 8.
This is subtraction.
Oh,
6 over 8.
No. Yeah. Sorry. 6 over 8.
Divide by
yeah.
2.
6
Divided by 2. Yeah.
And it's 3 over 4.
Good. That's right. Brilliant. All right. Now come the fun ones. Now we're gonna change denominators. I'm gonna delete. get this out of here. Because now we gotta get the same denominator. This is where it gets hard. It's not that hard, it's just like harder because you're not just subtracting first ones. So 1/2 plus 2/3. Let's do this one together, and then I'll let you try some on your own. So we can't do this because the 2 and the 3. We gotta find common denominators. So I set it up like this is how I've been setting it up.
It'll be 6.
It's gonna be over 6, yeah. So, but what are you gonna multiply the 1/2 by?
1/4.
No, it's gotta be 1.
4/4.
4/4? Yeah, that's fine. 4/4. No, it's not gonna be fine. You're gonna get 4/8, and you can't multiply 3 by anything
Oh, no.
but 8.
No, 3/3.
3/3? You get what? 3/6? What about this bottom one? What do you think, Ruth?
1/1.
1/1 is going to give us over 3. What can we multiply this by so that it ends up having 6 in the denominator?
2.
2? Yep. 2/2. 4/6. Now that we have this, we can rewrite this, let's do this, as 3/6 plus 4/6. Then we get 7/6. I think that was the answer 1 minute ago, coincidentally. Yeah, it was, we had 5/6 plus 2/6. So, the tricky part here is changing and getting them to have this correct like this. I'm gonna give you all one to practice now. Five over 9 plus 1/2. Solve that puppy.
I got 6 for the top one.
Okay. Sit for 5/9. Oh, well we
No, no.
we can't add these because we have to get these to be the same.
So 5/6.
Sorry, I don't know where.
I mean 5/3.
I didn't mean to write this. I meant to write 5/9.
Yeah.
5/9, and then 1/2. So we've got to make these have the same denominator. What can we multiply them by? It's got to be something over something, the same number over the same number.
3/.
If you're in doubt, you can always, for this one, you can do 2/2, and for this one, you can do 9/9. If you're in doubt, you can always multiply this one by the bottom number here, like 2/2. See that? And you can multiply this one by 9/9. Because they're both going to end up with
The same.
the same, because down here you're doing the same thing, it's just flip the directions. 9 times 2 and 2 times 9. And here we have 9 times 18. So then what's our answer? This is the same as 10/18. plus 9 over 18, 19 over 18. Alright, I'm going to do some subtraction now, okay? So really subtraction is not any different other than like, this is the difficult part, making sure they have the same common denominator. Let's try 4/5 minus 2/3. 4 over 5 minus 2 over 3. Go to town on that one.
So we're doing the 4 over 5.
Yeah.
And then the 2 over 3.
Yeah.
For the top one, can we do 1 over 1 and the bottom one 2 over 2 and we still end up with 4 over 5?
So we'll end up with 4 over 6 here, you're saying?
So what number can I use for the top to be 4 over 5? 5, just like the top one if I was doing 1 over 1.
Well, we want, we can't get 3 to go into 5, so we can't use
Right.
1 over 1 here.
So what can we, because that's what confuses me is the 5, right? Nothing really goes into 5.
Well, we're
But
not
what-
thinking what goes into 5, we're thinking what can 5 go into, that 3 can also go into.
So we're 15.
So like both 5 and 3 go into 15. So we could say 3 times 5 is 15. 4 times 3 is 12. We can say 2 times 5 is 10 and 3 times 5 is 15. Now what's the answer? I'm not even going to rewrite it. What's the answer to the problem?
The denominator is
Bottom number 30,
right?
Sorry?
The denominator is almost as some support, right? Or you have to.
When you're subtracting? No.
Alright, so.
we subtracting those two fractions?
Yeah, 12 over 15 minus 10 over 15. What do we come up with? Denominator just stays.
Stays 15.
2 or 15.
2 over 15. Let's try one more of these, and then we'll be rocking on out of this subject. And this is the hard part, the getting them to have the common denominator. 2/8 minus 1/6.
So here we can do the 2/2, right? Because 2 goes into 6 and it also goes into 8.
Let's see, 2/8, 1/6. You're saying we can do what?
2/2.
For the top one?
Mm-hmm.
Over 2. That's going to be 4/16. And what are you suggesting for the bottom one?
Over 16. No, scratch that.
Yeah, because we can't make
It won't,
6
yeah, the
doesn't
bottom
go to
won't be
16.
16.
So that'll have to be 3/3.
You're going to do 3/3 on the top? Okay. What could, so now Ruth, tell me what could we do to get this one to be over 24?
To be over 24?
Or under something over 24, yeah. What could we do here to make them both have 24?
4.
Yep,
4 over
4 over 4. Yep, exactly. So 4 times 1 is 4, 6 times 4 is 24. So we can subtract. So 6 minus 4 is 2 over 24. And we actually need to divide that by 2 to get 1 over 12. Oh my goodness. 1 over 12 simplified. And then that's our answer. Now we could have done this a longer way. We could have gone like so. We could have gone, 6 over 6. We would have had 12 over 48. And we could have gone 8 over 8. There's not just one right answer here. We would have had 8 over 48. That's fine. It's just a bigger number. Like we would have 12 over 48 minus 8 over 48, which is 4 over 48. And then we would have had to simplify that. And when we divide each of these by 4, they come out to 1 over 12, the same answer. Right, the same answer. So it's all the same. All right. Do you all want to take like a break for like 3 minutes, use the bathroom or anything, or keep rocking? All right. Keep rocking and rolling. Now we're gonna switch topics. Not topics. So we're gonna keep talking about parts of things. So fraction is one way. You can say like I have half a pizza. We can also use decimals, like you've seen like 0.516 or something like that, for example. Now sometimes in the SVAB, they're going to want you to do things to decimals, operations. Remember, an operation is addition, multiplication, exponents, all that stuff. So the most important thing to remember is to get everything lined up. So for example, if I have 0.77 plus 14.6, I'm going to have to write this out, but what I can't do is say like this. This is wrong. That's really wrong. Don't like even write that one because it's out of place. You have to remember to get the decimal points lined up the same. And then you know there's an invisible 0 there. So this decimal point, line them up the same. And then you can add 7, 3, 1, 5, 15.37. Here's a similar example, 5.5 minus 0.41. We cannot just go 5.5 and then put 4.1 point right beneath it. That's gonna mess you up.
You gotta put the point and then
Yeah,
41
you
and the
gotta put
invisible zero.
Point here, yeah. So we gotta add a 0, 10, 9, 4, 0. The 5 comes down, 5.09. Now with multiplication, it gets a little loose with the rules. Like you actually can put them in different places. I'm gonna tell you not to do that just because I think it's better if you're in a habit of getting them lined up just for the process. I'm saying that mostly for YouTube because even though most of my math videos are private, someone came on there and was literally trash talking in the comments of one of my ASVAB youth video, ASVAB math videos, and it kind of upset me. I proved them wrong, but it was just stupid. So just so you know, this is the way I'm showing. It's not the only way to do this, YouTube. So let's say, well, let me do it like this: 0.7 times 0.03. When we set it up, I'm going to tell you to write 0.70, 0.03, and just get it nice and lined up like that, so that it's all lined up. 3 times 0 is 0. 3 times 7 is 21. Now we put a placeholder 0 here. 0 times 0, now this is easy because it's just zeros. 0, 1, 2. Now, and then technically there's a 0 here, so I'm going to write here. Now we have to count how many are behind the decimal place here. So we have 1, 2, 3, 4. 1, 2, 3, 4. So we have 0.0210. Let's try division. Good to erase this one?
Mm-hmm.
Let's try. Hope I don't mess this one up. Now 77.5 divided by 25. Yes. So here we're gonna have 77.5, 25. You just need to remember, well, I'm just gonna do this first. 25 goes into 77 3 times. 3 times 25 is 75. We subtract the 2, we bring the 5 down here. 25 goes into 25 one time. The answer is not 31. We have to bring the decimal point up here. The answer is 3.1. So that's division. I'm going to show you another example of a division problem with decimals. You might deal with this. You might deal with 278 divided by 3.6. Now something we can't do, like it just doesn't really work, is to have like a decimal out here. This is just ugly. It's not gonna work really well. So if you have a decimal out here, you need to move it over 1, and when you do that, you're gonna move this decimal over 1. So you're effectively just adding another 0. So instead of 278 divided by 3.6, you have 2,780 divided by 36. We just moved the decimal point over 1 here and moved it over 1 here. What we're technically doing is multiplying them both by 10. So now 36 goes into 278. This is a goofy problem to solve. 36 times 7, I think it is 6 times 7 is 42. 3 times 7 is 21, or 242. I think that's right. 242. Let's see what we come up with. 6, 3. Oh no, it is 36. That's not right. 36. Let's say 36 times 8. Oh, I made it to be nice. 6 times 8 is 48. 8 times 3 is 24, plus 7 is 278. So that goes in very nicely. 8 times 278, remainder of 0. 36 goes into 0, 0 times. So the answer is 80. 278 divided by 3.6 is 80. It's the same thing as 2,780 divided by 36. Excuse me. So now let's talk about, now that was just like a decimal intro, let's talk about going from decimals to fractions and fractions to decimals. Let's first talk about F2D, the YouTube World Internet. This stands for fraction to decimal. All you have to do is do the division. So like 3 over 16. You're just going to say 3 goes into 16. Sorry, other way around. I always get that mixed up. 3 into 16. You're going to have to add a decimal and a 0. 16 goes into 30 once. 16. That is 10, 4, 2, 1, 14. Then you bring 0 down. 16 goes into 140. Why did I pick this one? This one's annoying. 16 times 7, 2, 4, 7, 112. Let me try 16 times 8. Just try 16 times 9. 4, 5, 9 plus 5 is 144. That's not it. 16 times 8. 8, 4, 128. 10, 2, 3, 1, 0. So we'll bring another 0 down. Oh, this goes in 8 times. I should have written that there. That's 7. 16 times 7, what did we say that was? I should have erased that. 2, 4, 112. That's 8. Yeah, this is, I don't know if I worked this before I picked this one, it's just ugly. Bring a 0 down. How many times does 16 go into 80? Let's see. I think it might go in 5 times evenly. Probably not my luck. Oh, it does go in 5 times evenly. You follow that? I was doing a lot of like multiplication and stuff. But that's just how you go 3 over 16 to be 0.1875. Got one for you that I want you to try. To go from 9 over 25 to a decimal. So before I get you started on the math, what's going to go inside here?
25, 9.
25 here?
And 9.
9, yeah. No, it's going to be the other way around. So now I'll get started on that.
I don't even know how to start.
Yeah. So 25 doesn't go into 9.
No.
You gotta add a decimal place into 0 and see does 25 go into 90.
25 goes into 90 3
Three.
times, yeah.
What's 25 times 3?
75.
What's the remainder here? Or not, remainder's not the right word. How much less is 15? Yeah. Now what do? I put a 0 here and bring it down. How many times is 25 going to 150?
25 goes into 156 times.
Mm-hmm. Yeah. So that's your answer.
0?
No. Well, I mean, it
Oh.
is 0. Your answer is
30.36.
0.36, yeah. Here's an example. This one, 1/3. What goes in the house?
The 1.
1. What goes out here?
3.
Do that, puppy.
So 3 doesn't go into 1, so it's 1.0.
Yeah.
Make it 10.
Yeah. How many times does 3 go into that?
3 times.
Okay. Tell me what to do next.
So add 9 at the bottom.
The remainder, yeah.
Now what?
Subtract it. You're gonna leave 1, bring it over 0.
Now what?
Point on top, yeah.
Now what?
You will circle this again. Yeah. It's still gonna be the same.
How long are we gonna do this?
Forever.
Forever, yeah. You see a pattern? Jermaine's like, yes, I could do math forever. I must have died and gone to heaven.
Definitely not heaven.
Very lovely place. So here's the thing we can do with these when they go on forever. You can just put a line like that over, and this line represents that same number keeps going forever. So if you get in a situation like that, there's a problem on one of the quizzes that includes that. Not includes that, but that's part of the answer. Let's do the other direction, decimal to fraction. This one's like, I don't like this part. This part's annoying. Right. Now let's take 0.75 and turn this into a fraction. How can we do this? This is I actually don't quite remember. Sorry, YouTube. I'm remembering as I say it. So what we're gonna do is we're gonna say 0.75. We're going to move the decimal point 2 places, so we get 75, and then we're going to put it over 100. It sounds kind of weird, doesn't it? So it's going to end up being 75 over 100, and that's a fraction right there. And what we can do then is we can simplify it. We can say divide each of these by 25, and we get 3 over 4. So we have to move the decimal point 2 places, and then put it over 100. Now, if it was a bigger one, if it was like 0.75000, we'd have to move the decimal point more places, and then put it over an even bigger number, like that. Why don't you try very similar this one, and instead of just working on your own, talk me through. Now what do you want me to do? 0.35, how can I turn this into a fraction?
The same thing, the dot, move it to the side and do 35.
How many times?
Twice.
Twice, okay. And then,
35 over 100.
yeah. Then what are you doing?
Divided by
Alright.
Oh, sorry, I didn't mean to put the number. What number you
It
want?
could be, yeah, divided by 5.
5? Okay. What are you gonna get? 7.
Over 10.
What? 20, yeah. That's the most you can, that's simplified. Good. See, that one's not too bad. I just think it's kind of annoying for some reason. We've got 10 minutes left. I'm torn.
Yeah, I feel like I've been run over by a trick.
Yeah, I think we're gonna end it
Math is the worst thing ever.
because the next stuff, the percents, is like pretty important on the ASVAB, and I don't want you to do it at the very end, and I also don't want to do it with 10 minutes left. So, would you mind hitting the video button?